Hello, 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 guys. We're back again after a little break with another video for AP Chem, and we're going to be looking more at some basics. And today, specifically, we're looking at balancing equations. So, how do you balance equations? So, before you even start, there's a few things you need to know. So, first things first, always write out your unbalanced equation with a blank space in front of each reactant and in front of each product, just so you can have some space to play with the coefficients. And then you're going to count out your number of atoms on each side of the equation. Your reactant side, you'll count it out, and your product side, you'll also count it out. And when you adjust your elements on one side, make sure you're looking to make sure it matches up on the other side to make your equation truly balanced. So let's dive right in and get into a practice problem. So let's balance the following equation. Na3PO4 plus MgCl2 plus NaCl plus Mg3 PO4 2. So I know it looks pretty complicated at first, but let's break it down. Starting from our first reactant. So in our first reactant, you'll see that we have Na3 and PO4. So in this case, if we wanted to balance it out on the table, then we could leave the PO4s intact since it's the same on the reactant side as well as the product side. But for simplicity's sake, we're going to keep everything as its own element. We have our unbalanced equation right here without the coefficient. So starting with our table, we're going to have our reactants here, our products here, and we'll just count it out. So let's start with Na3. So let's start with our Na. How many NAs do we have on the reactant side, the left side of the equation in this case? We have 3. And then how many do we have in our product side? Before balancing, we have just 1. So next atom, the P. So how many do we have on our reactant side? We just have the 1. How many do we have on our product side? We have this P in this PO4, but there's a 2 coefficient on the outside, so we have 2 P's. And then in the O, we have 4 on this side, and we have 4 in this side too, but we also have to multiply it by the 2, so we have 8 oxygen atoms on the product side. Next up, Mg. So for Mg, we have 1 on the reactant side, and we have 3 on the product side. Alrighty, and our last atom, Cl. We have 2 on the reactant side, and we have 1 on the product side. So, where do we start with this? I think that the easiest way to start off these types of problems is just to look at your simplest ions, or your simplest atoms and ions. So, if we look at the oxygen here, we have 4 on the reactants and 8 on the products. And you notice the same thing with this phosphorus atom. 1, it doubles. 1 on the reactant side, 2 on the product side. So, keeping that in mind, how should we approach this? We should add 2 to the reactant side, double it. So if we put the coefficient of 2 here, sorry about that. We put the coefficient of 2 here. Now we have 6 sodium atoms. So how do we balance that out on the other side? Well, if we're looking here, our 2, our 3, 6. So we're just going to have to put a 6 in front of this NaCl. And then, yeah, from here, we have our 6 NaCl. So now we have to balance out Cl. We now have 6 Cl. So we're going to need to balance this out with this. This is Cl2. So 2 times what equals 6? Just 3. So we'll add our 3 in, and then magnesium, we'll double check, make sure it's all balanced. 3 mg's on this side now, and mg3. So we can write 1 or leave it blank there. So this is going to be our balanced equation, and that is the table that we use. And yeah, should be pretty simple. Oh, forgot to mention too, this one is a double replacement reaction, because you're starting off with this and it stays, but you have to keep in mind and notice how this PO4 switches and goes bonds with the magnesium, and the Cl2 switches and bonds with sodium. So yeah, and this one's a double replacement reaction. Okay guys, now that we got that out of the way, let's look at another problem. And looking at it right away, it's pretty clear that this is a combustion reaction, because we have our C something, H something, plus O2, and then it makes CO2 and H2O. So in case you didn't know, O2 is just fire, and the combustion is basically an explosion. So you're taking one of these carbon chains with hydrogens attached, adding oxygen that's heated, and then it makes a fire. Then your end result is going to be CO2 and H2O. But the tricky thing with these is making sure that you're counting everything and that you're balancing out your molar ratios. Okay, guys. Okay, so now we have our new equation here, unbalanced as of right now, but just looking at it, making a table for these types of problems is a little bit harder, but as long as you can keep everything in check and keep track of everything, then you should be good. So let's make our reactant side, our product side, and let's start off. So for carbon, we have 3 on the reactant side and 1 on the product side. For hydrogen, we have 8 on the reactant side and 2 on the product side. And for oxygen, we have 2 on the reactant side and 3 on the product side. So for this one, let's start off nice and easy, making the simplest choice we can make here. So we're going to look at our carbon atom here, and we're going to take note that it has 3. So since this carbon just has 3, and on the product side it has just 1, we can multiply this, and then we've balanced our carbon. So next things next, we're gonna have to keep in mind that this O2 now has 6 plus this extra 1 from the water. So keeping that in mind, we're gonna look to our next thing, our hydrogen. So for hydrogen, we can see that we have 8 hydrogens on our reactant side, and we have 2 on our product side. So that's also a pretty simple thing to fix. We just add our 4 here, and we balanced out our hydrogen. So now our carbons and hydrogens are good, but we just need to find out exactly how much O2 we have. So looking at it from the CO2, we have 6 oxygen atoms. And from our water, we have just 4. So in total, we have 10 oxygen atoms. Or in this case, it would just be 5 O2 molecules. So yeah, this one again is called a combustion reaction. And yeah, just making sure everything checks out. We have 3 carbon atoms here, 3 carbon atoms here, 8 hydrogen atoms here, 8 on this side, 5 O2 or 10 oxygen atoms. We have 6 plus 4. And yeah, that is about it.